Welcome back. I scared you, I'm sure. I decided to have more energy. But anyway, I'm actually fasting today, but I won't go into it too much. But I do this thing. Well, I don't want to go too much into my personal life, but I've realized that I eat one meal a day now, and I have so much energy. It's unbelievable. But anyway, hope you don't think I'm crazy. But back to the SAT videos. So let's see. We're on problem number 15. Problem number 15. So I drew it ahead of time because I didn't want to waste your time because it's more valuable than mine, I think. Considering because I have so much time now that I only eat one meal a day. But they say in the figure above, triangle PQR, so this is P, triangle PQR is equilateral. It's equilateral, and this is an SR and TV intersect at point P. What is the value of Y? So let's just use all the information they give us. This is an equilateral triangle. So what do we know about equilateral triangle? All the angles in an equilateral triangle are the same. This is going to be 60 degrees. This is going to be 60 degrees. And this whole thing is going to be 60 degrees, right? Well, if this whole thing is 60 degrees, then what's x? Well, there's three x's, and they're equally splitting it, right? So this is 20 degrees. This is 20 degrees. And this is 20 degrees, right? And angle y. Well, what's equal to angle y? If from our geometry module we know that angle y is equal to the opposite angle, right? Angle y is going to be equal to. So we've got to make sure you just got to pay close attention to which lines this is. So that line and that line, right? So the opposite angle to angle y is this angle right here, right? So that angle is just two of the three x's, so it's 20 and 20. So angle y is equal to 40 degrees. It just equals two of these x degrees. That's it. All right. Number 16. Maybe I could do it here with this kind of toothpaste colored ink. Let the operations triangle and square be defined for all real numbers a and b as follows. I like these problems. A triangle B is equal to a plus 3b, and then a square b is equal to a plus 4b. And then they have this thing: if 4 triangle of 5y is equal to 5y square 4. What is the value of y? Well, this might seem bizarre to you, but we just have to map these functions to. I mean, this is just a functions in disguise, right? A function of really two variables. So let's say, so what is 4 triangle 5y? So let's go to the triangle function. That's this one, right? So in this case, a is 4, right? Because it's the number before the triangle. So that's equal to 4 plus 3 times b. Well, what's b? Well, b is whatever's after the triangle, right? B is whatever's after the triangle. In this case, it's 5y. So 3 times b would be 3 times 5y. 3 times 5y. Let me do some coloring here. This is just this, right? And then if I do the other side of that, 5y square 4. So in this case, so we're using the square. So in this case, 5y is a, right? So 5y is a, so that equals 5y plus 4b. 4, and what's b? Well, b is whatever's the second, whatever's after the rectangle, right? So 4b. So 4b is 4 times 4. And now we just solve. So let's see, 4 plus, let me just rewrite that. 4 plus 3 times 5 is 15y is equal to 5y plus 16. Let's take 4 from both sides. So you get 15y equals 5y plus 12. Take 5y from both sides. You get 10y is equal to 12. Y is equal to 12 tenths. And then we can reduce that, right? Divide the top and the bottom by 2. So y is equal to 6 over 5. And that is our answer. And you can, these are these kind of fill in the blank ones, so you can actually write that, bubble it in. The SAT wasn't like that when I took it. These problems are really good. Let's move on. Image, invert colors. All right. Number 17. I'm going to switch to magenta, bright magenta. Okay. In the xy coordinate plane, the graph of x is equal to y squared minus 4 intersects the line L at, so it intersects the line L at 0, comma p and the point 5, comma t. Right? These are 2 points on the line L. What is the greatest possible value of the slope of L? So this is interesting. So x is equal to y squared minus 4. So first of all, you need to realize this isn't how you normally write a function, right? You normally write it y is equal to x something. But what this is going to look like, x plus 4 is equal to y squared. Well, and you don't have to draw this actually on the SAT because it's going to take you too much time. But I think it's useful here to have a visualization of this, right? And if you have so the graph is going to look something like this: x plus 4. So it's actually in the negative. It's going to actually start at minus 4. It's going to go look something like this. The graph. Oh, whoops! I'm still using the line tool. So the graph is going to look something like this. It's going to start back here at minus 4 and then be. I think that's what. And then the line L, we can only assume, since it intersects it at 2 points, is going to look something like this, right? Where this could be 0, comma p, and this is 5, comma t. What's important to realize is that both of these points satisfy this relationship, right? Both of these points, because they're on this curve. They're on this curve. So we can do that with our math, right? We could write this as 0, comma, well, if x is 0, what is y? Well, 0 is equal to y squared minus 4. And we add 4 to both sides. Y squared is equal to 4. So y is equal to plus or minus 2. And that's the tricky part, right? Y is equal to plus or minus 2. Plus or minus 2. And then what does this equal? So if x is equal to 5, what is t? What could this term right here be? So let's see. 5 is equal to y squared minus 4. Y squared is equal to 9. Y is equal to plus or minus 3. So this is plus or minus 3. Fascinating. It's plus or minus 3. And actually, I drew this original graph. Since it's written this way, since it's not written as a square root, it actually would kind of do something like this. And where I drew a little funny, but you don't have to draw it. So anyway, this plus or minus 3. Why? So these are the possible 2 points we could have intersected. And what the question is asking is, what is the greatest possible value of the slope of L? Well, we want to figure out, well, if we want the greatest possible value, we want to go from a very low number to a very high number, right? The x values are fixed. But we want as great a possible change in y given that change in x, right? So if we want the lowest possible value here, we'll go with the negative 2. If we want the highest possible value of x, we'll go with 3. So let's see. So if we assume that, let's change in y is 3 minus negative 2 over change in x, 5 minus 0. And this adds up, right? So this 3 plus 2 is 5, or 5. It equals 1. That is the greatest possible slope. I'll see you in the next video.